We're looking at special or shortcut ways of factorising the difference of two cubes or the sum of two cubes. These two formulas here will help us out when we are factorising. If we wanted to expand a polynomial or the sum of a polynomial or the difference of a polynomial, then these two would be used. So let's have a look at our first one here. X cubed minus 27. All right, come back up to this particular one up here, the difference of two cubes. So what I'm going to do first of all is write this as the difference of two cubes, and it becomes x cubed minus 3 cubed. That should be your first step. Always look at it as cubes. All right, this rule up here says when you factorise, it is the first term minus the second term. Well, our first term here is x and our second term is 3. So it will be x minus 3. Okay, in the next bracket then, it says it is the first term squared. Our first term is x, so it becomes x squared, followed by the first term times the second term. All right, the first term times the second term would be minus 3 times x. So plus and a minus make a minus, so it is minus 3x. And then it is the second term squared. Now the second term is minus 3, so therefore minus 3 squared is positive 9. All right, let's have a look at the next one. So we're going to do exactly the same sort of stuff here, but this time if you can take out a common factor, because remember when we are factorising, let's see if we can take out a common factor first. That should always be your first step. So with this one, okay, with this one here, I'm going to take out a common factor of 8, and I've got x cubed plus 8. All right, looking inside the bracket now, can I write that as the sum of two cubes? Because that will help me. I don't want to have to do long division. So 8, and of course 8 is 2 cubed, so it's 2 times 2 times 2 is 8. So x cubed plus 2 cubed. So obviously now I'm looking at the second one there, the sum of two cubes. And what does that say? Well, the 8 stays out the front. All right, the 8 stays out the front. And then it is the first term plus the second term. First term is x, second term is 2. So it is x plus 2. Okay, in the next bracket, it is the first term squared. So it is x squared. And then it is take away the first term times the second term. Now the first term times the second term is 2x. Take it away, so minus 2x. Sorry, that should not be a bracket there. Minus 2x, and then it is the last term squared, and the last term or the second term is 2, so 2 squared is 4. So that is my final answer. That is fully factorised. And now we're going to look at our last one here. All right, again, we're just trying to make our life a little bit easier. So I'm going to come over here, all right, and take out a common factor. Now, it's probably important what common factor you take out here to make your life a little bit easier. So, yes, you could take out 16 because it's common to both of them, but we might be in a little bit of trouble in terms of trying to do difference of two cubes. What I would suggest here is take out a common factor of 2. So if I take out 2, I'm left with 8x cubed minus 27. Now, why have I done that? Well, have a look inside that bracket. Can I write that now as the difference of two cubes? So it's 2, and I'm going to use a square bracket there. I'm going to write 8 as 2 cubed. So therefore it's 2x all cubed. So my first term there is 2x. Take away. What's my second term? Well, 3 times 3 is 9, times 3 is 27. So take away 3 cubed. So you can see now inside the bracket, I've got the difference of 2 cubes. My first term being 2x, my second term being 3. So let's use our rule again. It is 2. Okay, I'll still use my square bracket just for a little bit. So it is going to be 2, the first term minus the second term. So the first term is 2x minus the second term. All right. In the next set of brackets, it's the first term squared. Now the first term is 2x. So what is 2x squared? It is 4x squared. Remember, you're squaring the whole term. So it's the first term squared plus the first term times the second. The first term is 2x. The second term is minus 3. So minus 3 times 2x is minus 6x. And then the last term there is the second term squared. Now the second term is minus 3, but minus 3 squared is positive 9. And I'm just going to tidy that up with my bracket. So it's 2 bracket 2x minus 3 bracket 4x squared minus 6x plus 9. Now that is fully factorised. I can't take anything else outside of those brackets, so that is done. Expanding cubics. This can be quite tricky, so we just need to be really careful with making sure that we think about it and do it step by step. So this first one is the first term minus the second term, all cubed. Now if you go back and have a look at your rule for that, x minus a cubed, that's what you're looking at. And the expansion for that is the first term cubed minus 3 times the second term times the first term squared plus 3 times the second term squared times the first minus the second term cubed. Now that can be tricky, so let's see how we would go about doing it now for the one that we've got, which is x minus 2 all cubed. So x minus 2 all cubed. Okay, what is our first term? It is x, so it is x cubed. Okay, now it's minus 3 times the second term, and our second term here is minus 2. All right, and our first term squared, and our first term is x, so times by x squared. All right, now what have we got for this bit? It becomes plus 3 times. What's the first term? The second term is minus 2. So it's minus 2 squared in this case, times the first term, which is x, minus the second term, all cubed. So minus 2 cubed. See how tricky that is? Let's be really careful with that. All right, let's tidy it up a little bit. So that becomes x cubed. Now you get minus 3 times minus 2 is a positive 6. So you end up with plus 6x squared. All right, tidying this bit up. Minus 2 squared is 4. 4 times 3 is positive 12. All right, and the last bit there, minus 2 cubed is minus 8, but you've got the minus outside, so that becomes a minus times a minus is a positive 8. So, as you can see, quite tricky. The next one is different because the two terms have got a plus in the middle. Still cubed, but a plus. So what was the rule that we had on the other page? It was x plus a cubed. So the first term plus the second term cubed is equal to x cubed plus 3 times the second term times the first term squared plus 3 times the second term squared times the first plus the second term cubed. Let's put in what we know about this one. So we are looking for 3y plus 2 all cubed, which means in this case that our first term is 3y. Our second term is 2. Let's be very clear about that. So we are now looking to cube the first term, which is 3y all cubed, plus 3 times the second term times the first term squared. So the second term is 2 times the first term all squared, so that would be 3y all squared, plus, okay, 3 times what? The second term squared. Now the second term is 2, so it's 2 squared, times the first term, which is 3y, plus, and the last bit there is the second term cubed, so plus 2 cubed. Let's tidy all of that up. So 3y all cubed. Well, 3 cubed is 27, so it's 27y cubed. Be careful with your signs. Next one, I've got 3 squared because that 3 is inside the bracket. So 3 squared is 9. 9 times 3 is 27. 27 times 2 is 54. So it's plus 54y squared. Next one, 2 squared is 4. 4 times 3 is 12. 12 times 3 is 36 plus 36y. And then the last bit there, 2 cubed is 8. So there's lots of different ways you could make mistakes here, particularly with the signs, but the most important thing that you can do is identify what your first term and what your second term is. So here, first term was x, second term was -2. In this one over here, the first term was 3y, second term was +2. And so if you keep thinking first term, second term, it will help you when you are putting them in, but you do have to be really, really careful. Now, the bottom bit there on your screen, you'll see what you can put into your calculator to factorize a cubic polynomial. And that's just the same way as what we would factorize a quadratic. So let's be really careful with these special ones.